Hey everyone, my name is Miles and I'm one of the SIs for Chem 1B this quarter. Today we're going to go over two practice problems to discuss the ideal gas law and combined gas law. So let's just jump right into it. So here's the first problem. It's asking us to find the moles of air given all these parameters. So first let's just write everything out just so we can visualize it. Okay, perfect. So that's all of our parameters right now. And as you guys can see, we're going to use an equation. It's going to be the ideal gas law, which is PV equals nRT. That's because we're given all these different conditions that match this equation. And we're trying to find moles n, so let's just rearrange this equation to solve for n. So if we move RT over to the other side, we get this equation. And then we have all the parameters we need except one thing, which is the R. So there's two types of R we're going to use for this chapter in this class. The first one is 0.08206 liters times ATM over moles times Kelvin. And this is definitely going to be the more common one that we're going to use because it's an ATM. And most gases are an ATM because it's at sea level and it matches what we do practically really well, very well. And the other one, that's going to be 8.314 liters times kilopascals, moles times Kelvin. Or it could be written as joules over moles times Kelvin with that same R value. So you could have either units. But again, we're going to use this one in this case especially. So if we plug in all the values, we get 6.8 ATM. Volume is 2.36 liters. 0.08206 liters times ATM over moles times Kelvin. And then last is temperature. But as you guys might have noticed, the R has a unit of Kelvin, but the problem gave us a unit of Celsius. So we need to convert between them and to get Kelvin. So a formula that we always use is Kelvin is equal to this, whatever the Celsius value is, plus 273.15. So in this case, we have 17 degrees Celsius plus 273.15. That's going to give us a value of 290.15 Kelvin. So we're going to plug that in right here. And if we do this calculation out, we're going to get a value of 0.67 mole. Perfect. And for most of these problems, we're actually going to use Kelvin because it's an absolute and it doesn't have any negatives to it, meaning that Kelvin can never have a negative value. The lowest, smallest Kelvin value we can possibly have is a temperature equal to 0 Kelvin, and that's absolute 0. But in Celsius, as you can see, or just generally, we could have a Celsius value of like negative 20 degrees Celsius, just for example. So that's why we use the Kelvin one. And for most of the problems and calculations, we want to use Kelvin. So if you're a bit unsure which one to use, I would just stick with Kelvin. Yeah, it's a good, safe bet. Moving on to the next problem. So kind of a similar problem in this case. We're given a bunch of parameters, so let's just write all these down. So the volume, it says, is 5 liters. The temperature is 20 degrees Celsius. it also gives us another temperature too, so let's write that down. It's equal to negative 25 degrees Celsius. And it's asking what is the volume. Now, as you guys might have noticed, we're going to use the combined gas law in this case. So that's P1 V1 over T1 is equal to P2 V2 over T2. And something else to notice is that it says assume that pressure is the same inside and outside, meaning it's constant. So we can eliminate it in this case because it doesn't change at all. It's the same value. So if a problem ever says assume it's the same or assume it's constant, you can just eliminate it from this equation. So we're going to have V1 over T1 is equal to V2 over T2. Let's just label all of our volumes and temperatures. So we can say this first one is V1, and it's associated with another temperature, T1, and then we're looking for a V2 along with T2 that's given to us. So we need to find T2. So let's just rearrange this equation to find T2. So we're going to move, V2. We're going to move T2 to the other side to find V2. And then here's the equation rearranged. So let's just plug all these values in. But before we do, you guys, again, notice that we're in Celsius. Remember I discussed earlier, we want to use Kelvin for most of our problems. And in this case especially, we want to use Kelvin for it because right here you can see it's actually a negative sign. And we don't like negatives. We want the temperature to be absolute without negatives because it makes the calculations easier for us. That's just a rule to stick by in a lot of chemistry, is that we're going to use Kelvin for not all of the problems, but especially in gases we want to use Kelvin. So we want to add 273.15 to both of them. And then for the first problem, we're going to get a value of 293.15 Kelvin. And the second one, we're going to get a value of 248.15 Kelvin. So now we're in Kelvin, awesome. So now we can plug these values into our equation. So T2 is going to be 248. Our volume is going to be 5 liters. And then our T1 is going to be 293.15 Kelvin. And the Kelvins cancel. And if you do this calculation out, you're going to get a value of 4.2 liters, which is the correct answer. Okay. So that wraps up both problems for today. Hope that helped. Good luck with studying, and I'll see you guys next time.